Hello everyone, today we are going to see inverse of matrix. Now let A be any non-singular matrix, then its inverse is given by this formula. What we have here, A inverse is equals to adjoint of A upon determinant of that matrix A. Here check that this determinant of A is not equals to 0. That means when this determinant of A is equals to 0, this means that A inverse is not exist, right? That means to exist inverse of matrix, that matrix should be non-singular matrix. Okay, we can check this is by one example. If we have this matrix A of order 2 by 2, we will check whether this inverse exists or not. So how to find its determinant here? Yes, we have to write all these elements. This is here 1, 2, 3, 4. And how to solve this one here now? This is 2 by 2 determinant. So how to solve? We have to do the cross multiplication of this here 1 into 4 minus of 2 into 3. So we get here this is minus 2 and this is not equals to 0. That means what? Here determinant of A is non-zero, right? That means here A inverse exists. Yes, that means this determinant A is non-zero, so that matrix is non-singular. So its inverses exist. Now we have to find its inverse. How to find inverse now? By using this formula. So for this we need adjoint of that matrix A, right? So how to find now adjoint of this here? We know adjoint of this matrix here. This is what? Transpose of cofactor matrix, right? And we know how to find cofactor matrix. For this we should know all the cofactors, and for finding cofactors we should know all these minors. So we will find one by one minor here. We have here 4 elements, so we will have here 4 minor. Okay, so minor of this first element. How to find? By excluding this row and this column in which that element lies. So minor of this one is here 4. Then minor of this second element, this is here what? Excluding this row and this column. So this is remaining 3. So minor of this here, this is this element, right? Minor of this 4 here, excluding this and this. So we get here this one. Okay. So we get here all minors. So by using this minor, we have to find cofactors. So cofactor of this is here. Yes. This is 4 and next cofactor. This is minus 3. Its cofactor. This is here minus 2. And this is this cofactor of this here. This element. This is here plus 1. We know how to find all these cofactors. This is we have find all these cofactors by using this formula. Cij is equals to what? Minus 1 raised to this is I plus j into minor of that element, right? By using this, we have found all these cofactors. Yes, okay. So for our convenience, we have write down all these cofactor sign here. This is in one matrix. So when we have plus en, when we have this is I plus j is E1, right? And when we have this is negative, when we have this is I plus j is odd. Yes, that means when we have this is 1 plus 1, that is 2, that is E1. So we have taken here plus sign. When we have 1 plus 2, that is 3, that means minus 1 raised to 3. So this sign get here minus 3. Similarly for this one. Okay, so we have find all these cofactors here. So we will have to write here all these cofactors in one matrix. Yes. So how to write here all cofactors? This is by its position. This is 4 minus 3 minus 2 and this is 1. Right? Yes. Now we have to find its transpose, and transpose is called that adjoint of that matrix A. So we have to take now its transpose. What is transpose? By interchanging rows and columns. So we will interchange this row here in columns. Yes. So we got here adjoint of this matrix A. Now we have to find inverse. So how to find inverse now? We will put all this determinant and adjoint in formula. Adjoint of A upon determinant of A. So we get here determinant value. This is here. We get this is minus 2. So we will write here determinant value. This is minus 2 here. And this is adjoint. Yes. So in this way we have find this inverse. Now we can check here this matrix and this adjoint. When we have matrix here, this is 1, 2, 3, 4. We can find directly adjoint of this matrix. How to find adjoint of this one? Now let's check this matrix. This is adjoint of this one. What we have done? We have interchanged these elements, these diagonal elements. So we have written down here 4, 1. And what we have to do? We have to change the sign of this remaining element. So yes, when we have this is plus here, we have to change this sign. So this is, yes. So what we have to do, we have to interchange these elements, right? And for this one, we have to change the sign. In this way, we can find directly adjoint for 2 by 2 matrix. Yes. So in this way, we have find inverse of matrix by using this formula. So this is the required inverse for this matrix A here. So this is required. Thank you.